If you want to have the copy of the module, I've linked it in the description of this video. Lesson 4. The set of integers. To learn the set of integers, let's go to its universal set, which is real number system, starting with the natural numbers. Natural numbers or counting numbers are those numbers that you use to count with. You don't count with -0, -2. No, you start with 1, 2, 3, 4, 5, and so on. There are infinitely many natural numbers. The set of natural numbers, and it's going to be denoted by an n here, a fancy way of saying n. And let's open this, and it's going to start at 1, 2, 3, 4, 5, and so on. And if we add a 0 to the natural numbers, you would get whole numbers. And this is just a set with 0 and natural numbers. One property of natural numbers is when you add or multiply, it will always be a natural number. Take the sum of 3 and 5, you get 8, that is still a natural number. You multiply 3 and 5, that gives you 15, which is still a natural number. This is what you call closure, meaning if you add or multiply two natural numbers, it will always be a natural number. Take note, this is not true for subtraction or division. Now we move on to the integers. If you take whole numbers, that is natural numbers including a 0, and you add their additive inverse, meaning if you have 1, you'll have -1, so it will infinitely go from the left. Then let's go from -5, which is the additive inverse of 5, -4, -3, -2, -1. Let's close it here. You would get integers, and it is going to be denoted by a fancy way of writing z. Now for the closure for integers. It is true for addition, subtraction, and multiplication, but not true with division. Again, closure is if you take the sum of 2. Now closure is if you take the sum of two integers, let it be like -5 and -1, it will always give you an integer. Same thing with subtraction, same thing with multiplication. And then we have rational numbers. From the name itself, it is numbers that can be ratioed. If you can express a number in a fraction form, for example, we have 8.27, it can be written as 827 over 100. It is a rational number. Even integers are rational numbers. Why? Let's take -5 as an example. -5 can be expressed as -5 over 1. We have expressed -5 as a ratio. Another one, let's say 15. 15 can be ratioed as 15 over 1. So we can say natural numbers, whole numbers, and integers are rational numbers. What makes rational numbers so unique is that we can get a part of a number. A part of a number is not a whole number. For example, we have 1/2. This is half a number. We also have a quarter of a unit. We also have an eighth of a unit, and integers are a part of it also. Let's say we have 5.27. This decimal number can be expressed as 5/27 over 100. We have expressed the decimal into a ratio. So if you see a decimal, that is non-repeating, non-terminating. If you see a decimal that is terminating, meaning it has an end, then it is a rational number. There is also another branch called irrational numbers, but we're going to talk about that next time. Now we move on to the lesson proper, which is the introduction to integers. These are just your whole numbers and their opposites, or their additive inverse. Whole numbers greater than 0 are called positive integers. Sometimes it can be denoted as your z here and a positive sign. If your whole numbers are less than 0, then it is negative integers. Can be denoted by the z with a negative sign. But if it is a z without any sign, it is understood as both negative and positive. The integer 0 is neither positive nor negative and has no sign. Two integers are opposite if they are each other the same distance away from 0. For example, we have negative 5 and 5. How many units away are they from 0? Well, from negative 5, we have negative 4, 3, 2, 1, 0. We have 5 units. Let's go to the positive 5. How many units away is 5 from 0? We have 5. We have 4, 3, 2, 1, 0. That's 5 units also. So we have negative 5 and 5, and they are opposite of each other. Positive integers can be written with or without sign. It is understood if there is no sign, it is positive. But if it's negative, always put the sign. We have here a picture of the hierarchy of the numbers. Of course, we have natural numbers, 1, 2, 3, 4, 5, and so on. Whole numbers is just adding a 0. If you add negative numbers now to whole numbers, it becomes an integer. All of these are rational numbers. What makes a rational number unique is it can be ratioed. That is all of your fractions and some of your decimals. Some of the decimals are irrational numbers. One example are pi. One example is pi. Then if we combine rational numbers and irrational numbers, then we are in the real number system. You will learn later about imaginary numbers and even later complex numbers. For now, let us just concentrate on real number system. Let's do an activity before we end. A. In each of the following group of numbers, which is the greatest and which is the smallest? On the number line, if you go to the right, it means the number is bigger. And on the left, of course, the number will be smaller. If we take this group of numbers and plot them on the number line, we have 6 right here, we have negative 3 right here, and 8 right over here. We can already see which one is the smallest, which is negative 3, and we have the greatest, which is positive 8. Number 2, we have negative 5, 5, and 0. We know 0 is number 2. We have negative 5, 5, and 0. Take note, all positive numbers are greater than any negative number. We can already see that negative 5 here is the smallest. The greatest here is 5. Number 3, we have this set of numbers. We have 1 negative, so no question, this is the smallest. And among these 3, 12 is the greatest. Number 4, we have 2 negatives, but the larger the number in the negative value, the smaller it is. So between 106 and negative 50 is the larger one. So the smallest number here is 106. We have 99 and 400 for our positive integers. Of course, 400 is the greater number. Number 5, we have 3 negative numbers. The larger the number, the smaller it is on the negative side. This is the smallest. This is the greatest. Number 6, we have 1 negative, automatic. This is the smallest. Between 15 and 10, 15 is the greater one. Continuing on 7, we have this set of numbers, 1 positive. That means this is the greater number. And we have negative 5, negative 10, and negative 12. The larger the number in the negative, the smaller it is. And this is the smallest. Lastly, 8, we have this set of numbers, 2 negatives. We have negative 400 as the smallest number. And between 106 and 50, we have 106 as our greatest number. B. Arrange the group of numbers in ascending order. You start at the smallest, going to the biggest. We have here negative 3 as our smallest. Next up is 6, and then we have 8. Number 2, we have negative 5, 0, and then 5. Number 3, we have negative 13, then 5, then 10, and then 12. For number 4, we have negative 106, negative 50, 99, and 400. Number 5 is negative 8 as our smallest. Next is negative 6, and then 3. We have here negative 10 as our smallest, then negative 5. We have 0, 5, and 10. C. Find the absolute number of each of the following. The absolute number is the distance of a number from 0. And you can think of it as a very optimistic number because it is always positive. The notation for this is 2 vertical lines with the number in between. Number 1, the absolute number of negative 1. How many units is negative 1 from 0? Well, just 1. How about 1? Positive 1. It's still 1 unit away. How about 0? Well, 0 is 0 itself, so you don't have to travel anywhere. Negative 25 is 25 units away from 0. So you can just take a number, take its absolute, and it is always positive. Let's talk about the negative outside the number next time. Continuing on to 6, the absolute value of negative 50 is just 50. Absolute value of 41 is 41. Absolute value of 899 is positive 899. Absolute value of 1001, that is still 1001. I believe 10 to 18 just repeated, but to be sure, I'll just list them off as this. That's it. End.